On the pH of the following, 1 molar hydrofluoric acid Ka is equal to 7.2 times 10 to the minus 4th, and some ammonia. I'll begin with A. Do the H first. So this is a weak acid. It's going to go to an equilibrium value. It's going to look like this. Times 10 to the minus 4. So I need to set up an equilibrium problem. Initial change equilibrium. Initial is 1, 0, 0. Change minus x plus x plus x. Equilibrium, this will be 1 minus x, this will be x, and this will be x. So, this will be at equilibrium. And one thing I can do with weak acids is round this off down here to say it's equal to x squared over 1. But I'm not going to bother doing that. Just whatever. Who cares? I mean, just do it the long way. Whatever. If it was something other than a quadratic, I'd probably just round it off. So anyways, let's multiply all this junk out. I already multiplied all this junk out. What's all this junk? And what's the other junk? Oh yeah, it was just 1. So what am I doing? What am I doing with my life? Don't need a stupid calculator for that. I'm going to use quadratic formula. This would be much simpler if I had just rounded it off, but why do that when this is so much more entertaining? So this all gets substituted in there. I know why this is negative. This is negative. I was about to put a 4 again. Screw that junk. And this ends up being equal to, what did I calculate that to be? 0.027. The other one was a negative number. Plus or minus. This is a plus, obviously. A negative won't be a negative change. So, now what I need is the concentration, or I have the concentration, I should say. 0.027 be of this and this, and subtract this, but I don't really care about these other ones. All I care about is the concentration of hydrogen if I'm looking for what the pH is. pH minus log concentration of hydrogen. And this is equal to 1.57. So this is approached like a regular equilibrium problem, and I had to do the equilibriums to find out what the concentration of hydrogen was at equilibrium. Then I simply use the pH formula. Simple enough. Next, ammonia, 15 molar NH3, Kb is 1.8 times 10 to the minus 5. Yeah. I should write out the equation first, shouldn't I? Yeah, should probably do that. Again, looking for the pH, gotta find the equilibrium values first. Screw it up a bit. And water is not included because it's assumed to be constant because there's so much of it. And what was it? NH3, 15 molar. Okay. Change, this will be minus x plus x plus x. And this can simply be rounded to 15, but we'll just do it the long way again. And this multiplied out was, so I don't feel like doing all that again, it's a waste of time. It's x squared subtracted, oh yeah, that's what it was, 2.7. That's just this multiplied out and subtracted over. Quadratic formula again. Make sure you have enough space. X ended up being equal to, what was that? seconds. Now I'll use this concentration. This is a concentration for NaH4. I didn't mean A, NH4 and OH minus. But all I care about is this one.